634. And I've taken a look at 633. I actually have an extra step that you guys won't have in 34, but it says Mrs. Bgen is a loan officer at the Coast Bank and Trust. From her years of experience, she estimates that the probability is 0.025 that an applicant, or 2.5%, will not be able to repay his or her installment loan. Last month she made 40 loans. It's actually a fairly high loss rate, but oh well. What's the probability that exactly three loans will be defaulted? What is the probability that at least 3 loans will be defaulted? So first I have to find my mu. It's not given to me, right? The mean, okay? Well, the mean, remember, is that 2.5%, okay, are going to falter, and I've got a sample size of 40 in this case, or a population of 40, and so my mean is simply equal to, right, 2.5% of 40. Okay, that'll tell me on average, right, how many loans would default. It'd be 1 out of 40, and so I can simply say that this is equal to my number of loans times the probability that they might fail. So I had to do that. For you guys, your mu is given, right? Your mu should be that 2. Okay. So then my first one says what's the probability that exactly 3 loans will be defaulted, and what's the probability that more than 3 loans would be defaulted? Okay. So at least 3 loans will be defaulted. So we let's do the math, or we can just do the Poisson distribution again and take a look here. Statistical, I'm sorry, we'll come down to the P. I could also go to most recently used since I've been using that. But so I got a Poisson. My X is the 3, right? My mean is my 1. Is it cumulative? In this case, no. I'm looking for exactly, so I can hit a 0. And the odds of exactly 3 loans would be 0.06. Yeah, it's about 6% chance that exactly 3 loans would be defaulted. Wow, that seems actually kind of high. I have to go look at that and make sure. Then B says what's the probability that at least 3 loans will be defaulted? Okay, and I think on this one I'm gonna have to do, I think my answer is gonna be this. Okay, I think on this one I'm probably gonna have to do a complement rule. Okay, but let's go take a look and see. I'll see if I come up with the same answer there, right? But I do the statistical, I do the Poisson. My X is 3 again. Okay. My mean is my 1. My cumulative, in this case, I'm going to do a cumulative. So what I'm calculating here is actually what are the chances that 1, 2, or 3 loans are might be in default, or might be underwater, or whatever the term is that they're using. They got defaulted in there. Okay. And so it is cumulative that I want to do here. So I enter in a 1. Now I ended up with a different answer than what I had before. Before I got B2, and I got B1, and I got a 1. So I used a 2. Why did I use a 2 instead of that? I'm going to take a little break and see if I can figure that out. Shame on me, I made another error. Okay, and the reason I used 2 is because, again, yeah, I got to read the problem. Shame on me, I'll slap myself silly here, but it says, what is the probability that at least 3 loans, so that's going to be 3 or greater, right? And so when I'm going to do the inverse, I have to do this Poisson, but I have to do 2, right? because I'm looking at 3 or greater, so I want to know 2 or fewer loans, what's that probability, and then I'll do the inverse or the complement of that. So that's why I end up with this, and then I take 1 minus that. Don't forget this step in this case, 1 minus this. Oops, I didn't enter my equal sign. So equals 1 minus this. And there I have an answer. And so, yeah, I was misthinking a little bit earlier. This just saying that I have an 8% chance, only an 8% chance, that 3 or more would be in default, and this means that I have a 6% chance that exactly 3, so a relatively small chance that exactly 3 loans would be in default. So there you go. Sorry for my errors. Glad I figured them out, however. Hopefully making some of those errors and correcting them will help you guys along the way as well.